In this lesson, we explore constructing truth tables for the conditional and biconditional. To get us started, let's start with a statement, a conditional statement. Consider this statement. If you get an A, then I will buy you a car. Let's say this first, the antecedent is P, right? You get an A. And let's say the consequent is I will buy you a car. All right, so we call that the antecedent P and the consequent Q. Now, we're going to assume that this statement here, if you get an A, then I will buy you a car, this statement is true, except when I actually have broken my promise. Okay, so this statement will be true as long as I don't break my promise. All right. Of course, in symbolic form, we have this statement: if P, then Q. So let us examine the four cases for this conditional statement. All right, so I have a little table going here, folks. All right, so what are the different outcomes for P? Well, P could be true, and then Q could be true. That would mean you did get an A, and I bought you a car. My promise was kept, right? If P, then Q. So everything turned out perfectly, right? Another thing could happen is you get an A and I don't keep my promise. I don't buy a car, right? I don't buy you a car. Of course, this conditional statement is now false, right? If P, then Q didn't work out because although the antecedent was true, the consequent was false. Another thing could happen is if the P statement is false, but this is true. Let me move this board up a little bit. There we go. And make my table just a little bit bigger here. There we go. Now the question is, what about the conditional statement? Is this conditional statement, if P then Q, is it true or false? Well, let me ask you a question. If P is false, what does that mean? That means you did not get an A. And if you did not get an A, I've not broken my promise. So in this case, I guess I still buy you a car. I guess I'm still, I don't know, I feel generous or whatever. But the statement, if P then Q, is not broken, if you will. Like I never broke my promise. Even though you did not get an A, I still buy you a car. This statement is still true. All right. And then the last case is false, false. Now, did I break my promise here? No, I didn't break my promise. You didn't get an A, and so I did not buy you a car, right? And so I never broke my promise. So this is true. The only case where I break my promise is when you did get an A and I did not buy you a car. That's the one and only case where this conditional statement is false. All other cases, it's true. All right. So I think this is worth adding to your notes. All right. Said another way, the conditional statement, if P then Q, it's true in every single case except for when P is a true statement while Q is a false statement. All right, we're at our first example. We want to construct a truth table for this statement. Not P. If not P, then not Q. All right, because this is a conditional statement, the answer column in our truth table will be underneath this symbol. All right, let's go for it. All right, so I've got my table set up. Let's fill in the cases here. So P could be true, true, false, false. Those are the four cases, right? Q can be true, it can be false, it can be true, it can be false. This covers all four cases. All right, so then what is not P? So the negation of P is just the negation of these truth values. So when P is true, not P will be false. And when P is false, not P will be true. So then this will be false, false, true, true. Now this is my answer column, folks. Okay, I'll fill that in last. All right, not Q, same kind of idea. It'll just be the negation of. these truth values here underneath Q. All right, so then it will be false, true, false, true. Now remember, a conditional statement like this, a conditional statement is true in every single case except for when the antecedent is true and the consequent is false. All right, so I'm going to put a lot of trues, all right, on this in this column. All right, here we go. So false, false, it's still true. False, true, it's still true. Here it is, folks. True, false. That is the case when a conditional statement is false. All others are true. So this is our truth table for this statement. We know when this statement is true and we know when this statement is false. All right, we have a new statement, everybody. If P, then not Q and R. All right, so we have three different simple statements, P, Q, and R. So we're going to have 8 cases. All right, let's get our table set up here. Now, this is a conditional statement. Therefore, my answer column is right here. All right, let's fill in the possible P values. So you're going to have 4 trues, 4 false statements. I could barely fit it. All right. And then Q can be true, true, false, false. And we're going to do that again. True, true, false, false. And then we're going to have R alternate. All right. So true, false, true, false, true, false, true, false. Okay, so that's the pattern. And this covers all 8 cases. Okay, folks, let's go for it. Let's fill in our table. Now, the first column should be really straightforward because it is all of your p-values. It's these same exact p-values. So just kind of copy and paste those over. All right, I went ahead and did that. The next column would be not Q. So all we're going to do is negate all of our Q values. Let's go ahead and do that now. And again, I'm trying to be as neat as possible and making everything line up really nicely, especially these rows. I'm going to skip over this conjunction and go to R. This should be fairly easy because we just have to copy and paste all of our R values here. All right, I got that. Now let's fill in this conjunction together. Remember that a conjunction like this is like the word and, it's only true when both the antecedent, it's not a conditional statement, excuse me. This conjunction is only true when this statement here is true and this statement here is true. All right, so false, true, that's going to be false. Next one, we have a false, false, so that's false. But next we have true, true, so that's going to be true. True, false is false. False, true is false. False, false is false. True, true. All right, finally another true. And then true, false is false. So I only have 2, right? 2 trues. And that's right here in case number 3. And then I have another true down here in case number 7. All right, folks, so this is what we're looking for. We're looking at, I'm going to kind of highlight it here. We're looking at this statement here. If P, then this statement. All right, so you're looking at this column as your antecedent and this column as your consequent. Now remember, for conditional statements, a conditional statement is true in every single case except for when the antecedent is true and the consequent is false. All right, here we go. All right, true, false. All right, so that's false. Okay. Next, true, false. Again, that's false. What do we have here? True, true. That's definitely true. And then we have true, false. That's false. Next, being careful here. False, false. Still true. Next, false, false. Still true. Remember, you only get something false when the antecedent is true and the consequent is false. False, true, so that's true. Really, when I'm doing conditional truth values, as soon as I see that the antecedent is not true, then I can put a true statement right away, a true truth value. Like this, false, I already know that's going to be true. So false, false, so that's going to be true. All right, so then this is our answer column. We only have, what, three cases where this conditional statement is false. Case 1, case 2, and case 4. All other cases, it's true. All right, let's talk about the biconditional now. I think to get us started, we must understand that this biconditional statement, P if and only if Q, this really means if P then Q, and if Q then P. All right. So in order to figure out the truth values for a biconditional statement, what we can do is we can just explore the following. P, if P, then Q. Let's put that in parentheses. And if Q, then P. Let's construct a truth table for this statement here. It's a conjunction here so that we can understand when a biconditional statement is true. Okay, let's go for it, folks. We only have two statements here, and so let's fill in some truth values. I'm going to change the color here to blue. All right, P can be true, true, false, false. Q can be true, false, true, false. All right, cool. Some of these will be really simple to plug in. Here, for this column underneath P, just copy and paste all of your P values, copy and paste all of your Q values. Over here as well, copy and paste all of your Q values, and copy and paste all of your P values. Let's go ahead and do that now. Okay, folks, I have all of my P and Q values here. Let's talk about this conditional statement here. Oh, by the way, my answer column is here. It's a conjunction. All right, but we're not ready for that yet. Let's answer this conditional statement here. Now, remember that a conditional statement is true in every single case. It's true in every single case, except for when the antecedent is true and the consequent is false. So let's just do this. I'm going to look for that case. When is the antecedent true and the consequent false? Right here in case 2. This is when it's false. I'm going to go ahead and fill that in. All others will be true. It's easier for me that way. Same thing over here. So I'm only going to look for when the antecedent is true and the consequent is false. That's when the conditional is false. So here it is. True, false. That's when it's false. All others are true. Cool. Now it's time to answer this conjunction. I am comparing these conditional truth values to this one. But this is a conjunction. The only time a conjunction is true is when both of these statements are true. So true, true. Okay, that's true. False, true. False. True, false. False. And finally, true, true. Okay, true. So here we go. Remember, folks, this statement right here, this long statement, which is up here, this statement is this statement. And this statement is equivalent to P if and only if Q. So we find that this biconditional statement is true only when P and Q have the same truth value. That is when they're both true or both false. I mean, because look at this. Look at P and Q here. Because this is true, right? The biconditional is true. Watch this. P and Q are both true. Q and P are both true. So this is true. Go to the other true. When is the biconditional true? Look at this. P and Q are both false. Q and P are both false. So when they have the same truth value, the biconditional statement will be true. Look at when the biconditional is false. P and Q have opposite truth values. True and false, false and true, false and true, true and false. So I am going to add a statement for our notes. The biconditional statement, P if and only if Q, is true only when P and Q have the same truth value. When they're both true or both are false. Cool. I think we're ready to answer some biconditional questions now. All right, let's construct a truth table for this statement. Not P if and only if not Q, then R. All right, the outermost is a biconditional, so therefore the answer column will be underneath this symbol. All right, let's get started. It'd be really cool if you remember that since we have 3 statements here, P, Q, and R, that you're going to have 8 cases. All right, so we have P, Q, and R up here. Okay, and then we have our statement, not P, if and only if, not Q, if not Q, then R. Extend this just a little bit further. All right, cool, let's do it. And then this will be my answer column right there. All right, let's go for it. Do you remember the pattern? So P will be true, 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 false, 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 false. Q will be true, true, false, false, true, true, false, false. And then R will be true, false, true, false, true, false, true, and false. All right, so that pattern generates all 8 cases. All right, cool. For this column here, just negate all of your P values. All of these values here, just negate them. That'll go there. And then we can jump to this column here, negate all of your Q values, negate all of these values. And then for R, of course, just copy and paste all of your R values. No changes for that one. Okay, I got all those filled in. All right. Now let's fill in the truth values for this conditional. Remember that a conditional is true every single time, except for when the antecedent is true and the consequent is false. So I'm just going to look for that case. Here it is, case number 4. The antecedent is true, but the consequent is false. This is when it's false. Right there. Does that ever happen again? Yes, the very last case. The antecedent is true, the consequent is false, so it's false over here as well. But all others are true. So I'm going to fill those in. True, 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 true. All right. Now, in order to fill in the biconditional column, I need to compare this column here, right, not P, with this conditional column here. All right. Now remember, a biconditional is true only when the antecedent and the consequent, right, this statement here and this statement here have the same truth values. All right. False, true. All right, then that's false then. False, true. Again, false. Case 3. False, true. False again. Case 4. False, false. Same truth values. So that one's true. true, true. Okay, that's true. True, true. Okay, that's true again. Case 7, true, true. That's true again. Finally, true, false. That's false. All right, cool. Now, in a previous lesson, we talked about how if you have a compound statement for which you already know the truth values for each of the statements, you don't need a complete truth table. Let's look at another example like that. All right, for this example, we don't need a full comprehensive truth table because they want us to figure out the truth value of this biconditional statement when P is true, Q is false, and R is false. All right, so let's start with this statement. Not P, if not P, then Q. If and only if Q, then not R. All right, if P is true, that's given, P is true, then not P would be not true, which of course is false, right? And then Q is false, plugging that in. And then we have the biconditional statement. Q is false. And then we have this implies not R. That would mean not false, right? Because they told us R is false. So not true in the beginning, not true, that's false. If false, then false. And then if and only if false, then true. All right, let's keep going. Now, remember that a conditional statement is true in every single case, except for when the antecedent is true, which it's not, and the consequent is false. Therefore, this is a true statement. And then the same thing here. This is false, this is true. The only time this is false is when the antecedent is true and the consequent is false. So therefore, this is true as well. And now, the big reveal, the final answer. The biconditional statement like this is true as long as you have the same truth value, either both true or both false. Of course, in this case, they're both true, so the final answer is true. This biconditional statement right here that they gave us is true. When P is true, Q is false, and R is false. Okay, to wrap this lesson up, we're going to end with these 3 kind of vocabulary words here. First, a self-contradiction is simply a compound statement that is always false. A tautology is a compound statement that is always true. Now, an implication is a conditional statement that is a tautology. So an implication is a conditional statement. Remember, if P then Q, that is always true. Let's look at some examples. Consider this statement. P if and only if Q, and P if and only if not Q. Let's construct a truth table. All right, we have 2 statements, P and Q, and so we know how this goes. Let's start filling in our table. All right, now we're ready to consider this biconditional and then this biconditional. Remember, a biconditional is true when both truth values are the same. So true, true, that's going to be true, and false, false, that's going to be true. All others will be false. So let me fill those in. So this one's true, this one's true, but the others, since they have different truth values, will be false. Same thing over here. I'm looking for the same truth values, so true, true, and false, false. Those will get true truth values. The others will get false. All right, now we're comparing this column here with, you know what, instead of an arrow, I'm going to just circle it. I'm comparing this column here to this column there. I'm going to move this up as well, if I can. There we go. This is a conjunction. So the only way a conjunction is true is if they're both true. So true, false, that's false. false, true, that's false, false, true, that's false, true, false, that's false. So they're all false. So this statement that they gave us is always false. Therefore, it is, let's go to our vocabulary words here, a self-contradiction. This statement here is a self-contradiction because it's a compound statement and it's always false. All right, we have a brand new statement here. P and Q. If P and Q, then P or R. All right, let's construct a truth table. You have 3 statements, P, Q, and R, so you're going to have 8 cases. All right, I have all 4 cases here. What I'm going to do next is I am going to fill in all my P values, all my Q values, all my P values, all my R values. All right, I have them all filled in. A little sloppy, but I'm not really happy with how clean it is. But here we go. So I'm going to change the color here. All right. For this conjunction, they both have to be true in order to get true. So this will be true, this will be true, and that's it. All the rest get false. So true, true, and then the rest will be false. Because for a conjunction to be true, they both have to be true. All right, got it. Let's go jump over here. Or remember that in order for a disjunction to be true, just one of them has to be true. Or both, right? But at least one. So this will be true, 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 true. This won't be false. True, and then false. All right, so a lot of true. All right, so true. This one's false finally. And then true, and then false. All right. Now, we're comparing the blue columns, okay? That's why I changed the colors. We're comparing the blue columns in order for this conditional statement to be true. In order for it to, and it is true, it is true in every single case, except for when the antecedent is true and the consequent is false. So let me look for, when do I have a true statement over here for the antecedent and a false statement over here for the consequent? Because that is the one and only case where this conditional statement is false. All right. True, 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 false, true. No, I'm looking for true, false. False, true, false, true, false, false. Okay, there's never a time where the antecedent is true and the consequence is false. Therefore, this conditional statement is never false. In other words, it's always true. There, a little sloppy, but there we go. So, this is a conditional statement, right? And it's always true. Therefore, this conditional statement is a tautology. So our vocabulary words are here. A tautology is a compound statement, which is what we have. I'm sorry, I'm reading the wrong one. A tautology is a compound statement that is always true. This is a compound statement. It's a compound statement, all right? And it's always true. Therefore, it's a tautology. But even more than that, it's a conditional statement, right? And this conditional statement is a tautology. Therefore, it's considered an implication. Super cool. All right. Now, one last thing before we go. Because it's an implication, we can say, let me go back to our statement here. We can say this statement here implies this statement. P and Q implies P or R because it's an implication.